All right, guys. So far we've been building up to using the mesh current method in order to solve the circuit. And I have a T-shirt here that's a bit nerdy. You know, it says, "What part of this big circuit do you not understand?" Notice that that it's a very large and complicated circuit, um, but it's planar, which means that we could actually use the mesh current method in order to actually analyze the circuit. However, we're actually going to begin a little bit more modestly. Let's actually use the mesh current method to solve our first circuit example. So here we go. This is going to be the mesh current method example. And this is an example of a circuit with voltage sources only. Right. And the goal is to find the branch currents labeled IA, IB, and IC. And without further ado, let's actually take a look at the circuit. So the circuit is the following. We have an independent voltage source here, providing us with 60 volts. This is hooked up to a resistor there, a resistor there, one down here, another resistor here, a second voltage source, providing us with 20 volts, one last resistor here. And these resistors have the following values. This is a 4 ohm, a 2 ohm, a 10 ohm, 1 ohm, and a 3 ohm resistor. And the branch currents, which I'm going to highlight in green, are the following. There's a current IA flowing from left to right through resistor 4 ohm resistor. We have IB that flows through the 10 ohm resistor down this way. IC flows through the 2 ohm resistor that way. Right? So this is the goal. Right? We want to use the mesh current method in order to analyze the circuit. Now, first things first. One of the things that I really encourage you guys to do is whenever you have branch currents that are already in the circuit, it's a good idea to redraw the circuit and introduce the mesh currents without the branch currents being there. One of the important things in a class like circuit analysis is bookkeeping, being able to carefully keep track of your terms and things like that. And I have found through experience that if you try to clutter up your diagrams too much, right, by adding in those mesh currents, it's going to mess you up. So I'll do the same thing. I'm going to redraw the entire circuit. It's the same circuit that we had above with all the same elements. So we have our voltage sources, the network of resistors. This voltage source was a 20 volt source. We had one resistor coming down the middle, and then two last resistors going like this. This was the 4 ohm, 2 ohm, 10 ohm, 1 ohm, and lastly 3 ohm. Now, it should be very clear that we have two meshes here, right? And so I'm going to define two mesh currents because I have two meshes. And as I mentioned previously, I'm going to make sure that they're actually going clockwise. So here along the perimeter of this mesh, I'm going to define a current I1. Actually, let me do something very quickly. I feel like this color blue is a bit dark. I'm going to use a lighter one. So here, there we are. That blue looks prettier. So I have I1 moving around this way, and I have I2 moving along the perimeter of that mesh. Now what I'm going to do is I'm then going to take a look at identifying my independent current sources. And I'm going to do that by taking a look at the current sources in our circuit. Notice that there are no current sources, so we don't have any constraints. We can actually use and plug things directly into KVL directly. We will see an example later on of when we have a current source, how that actually reduces the number of independent mesh currents by 1. But this one doesn't have it, right? The next thing is I'm going to systematically use KVL. So I'm going to go ahead and use the mesh current method to analyze this. And I'm going to begin with KVL. So here I'm going to use KVL around mesh number 1. This is the mesh with the mesh current I1. So the sum of the voltages must add up to 0 around this mesh. Now I'm going to go ahead and begin right here, and then I'm going to move this way along my loop. So I'm moving in the same direction as the mesh current that I've actually defined. And since I'm actually going through the 1 ohm resistor, and I'm actually moving in the same direction in my loop, I'm going to add in the 1 ohm resistor, so that's 1 ohm, times the current that's flowing through there, and the only mesh current that's flowing through there is I1. So here, essentially what I've done, and hopefully you can see that, is in moving from this node to that node through resistor I1, I've picked up that term. Now, one thing that I also want to make mention of is notice that I have this unit here. That unit makes it very cumbersome whenever we're actually writing down the mesh current method equations. So I'm just going to write down the value of the resistor, omitting the unit, but keep in mind that there is a unit there that has been omitted. Right. So here, cleanly right below it, I have 1 times I1 for that voltage. I then am going to go up this way through the 60 volt source, and notice that I hit the minus sign first. So into KVL, I have minus 60, right? Usually I'd have volts at the end, but I'm going to omit that for simplicity. I then am going to go through this resistor in this direction. Notice that I'm going in the same direction as my mesh current. I'm going through the 4 ohm resistor, so I pick up a term of plus 4 I1. And then lastly, I go from there, that node down to this node, and keep in mind there are 2 mesh currents that exist there. I have I1 going down this way, I have I2 going up that way, and I am moving in my loop through that 10 ohm resistor down that way. I'm going in the same direction as I1, in the opposite direction as I2. So I pick up terms of plus 10 I1, right, for the first voltage going through I1, and the other one is minus 10 times I2, like this. In general, one of the things that I'm going to do is as I go through a branch where there are multiple mesh currents existing, I'm just going to go ahead and simplify this and say this is 10 I1 minus I2 because I'm going through I1 in the same direction, opposing I2. I've gone through all of my elements. I've finished with my loop. The sum of those voltages must add up to 0. So here, my first equation right here is this one. And this is coming directly from KVL. Now, one thing that I'm going to do is I'm going to go ahead and clean everything up by collecting terms. So I have 1 I1 there, 4 there, 10 from there. That's a total of 15 I1s. I also have minus 10 I2s coming from there. This negative 60 I can add over to this side. And this is going to be my equation 2. This one's important. I'm going to box it. So that is my first independent equation coming from the mesh current method. Now, that takes care of mesh number 1. Let's actually take care of mesh number 2. So for mesh number 2, I'm going to use KVL around mesh number 2. So the sum of the voltages around this new mesh must add up to 0. And let's go through this systematically like we did previously. So here, I'm going to begin up here. I'm going to go through my 2 ohm resistor in that direction. And notice I'm going with my current I2, so I pick up plus 2 I2. I then go through my 20 ohm voltage source this way. Notice that I hit the positive sign first. So I then have plus 20 volts. I'm going to omit the volts. I then go through my 3 ohm resistor in the same direction as I2. So I pick up plus 3 I2. And then I am going to go from this node to complete the mesh. I'm going to go back up this way. And notice that I'm going in the same direction as I2, but I'm opposing I1. So the term that I'm going to pick up now is plus 10 times I2 minus I1. That must add up to 0. I can once again clean this equation up and group things together. I only have a few I1s coming from there. There are negative 10 of them, so minus 10 I1. I have positive 10 I2s from there, 2 more, and then 3 more from there, for a total of plus 15 I2s. This 20 I can subtract to the opposite side, so minus 20. This will be my equation 3, this will be my equation 4. Right? Equation 4 is the important one. I'm going to box these two like this. Now, equations 2 and 4 constitute a system of 2 equations, 2 unknowns. I can actually solve for I1 and I2 using any technique that I actually want. So let me actually write this out very cleanly. My system of equations consists of the following. We have equation 2, which is 15 I1 minus 10 I2 is equal to 60. Equation 4 is minus 10 I1 plus 15 I2 is equal to minus 20. You can use any technique to solve these. My favorite is to use a calculator. So using a calculator, I'm going to get a value for I1 and a value for I2. So I have my calculator here, which I'm going to plug a few things into. So we have 15 I1 minus 10 I2, that's equal to 60. And then minus 10 I1 plus 15 I2, that's equal to minus 20. And if I solve for these, I get I1 is 28/5 of an amp. I2 is 12/5 of an amp. And you can turn these into decimals. This is 5.6 amps, and this is 2.4 amps, right? Now, I am going to highlight these, but I'm not going to box them. And the reason I'm not going to box them is that those were not what we were looking for. We have to go back. We solved for the mesh currents, but that was not the original problem. Remember, what we needed to do was we need to find the branch currents IA, IB, and IC, and we need to use the mesh currents to do that. So for the branch currents, we'll have a value for IA, we'll have a value for IB, we'll have a value for IC. Let's go back up to our circuits to identify them. So here, notice that IA is this current, and it is moving in the same direction through the 4 ohm resistor as I1. So IA and I1 are identical. Right? So we can definitely say that IA is the same thing as I1, which is 5.6 amps, which is good. Then let's take a look at IB. IB is this current, and we actually have two currents there. We have I1, which is a mesh current flowing down in the same direction as IB, I2 flowing up in the opposite direction as IB. So according to superposition, IB is I1 minus I2. So this is I1 minus I2. We have those values. This is 5.6 amps minus 2.4 amps, which gives us a grand total of 3.2 amps. Lastly, for IC, IC is going in this direction through the 2 ohm resistor. Notice that I2 is going in that direction. Notice that they're in opposite directions. There's only one current there, but since they're in opposite directions, according to superposition, IC must equal minus I2. But I2 we have, so this is minus 2.4 amps. This is what we wanted to get to. These are the branch currents that we were looking for. We have our branch current IA, which is 5.6 amps, IB, which is 3.2 amps, and IC, which is negative 2.4 amps. Now we can say that